Well, so we started discussion on that cell model, right? And when we have considered that the centralized potential is like infinite square well, then you have seen that potential can predict many closed cell structure or many magic number. Out of this many magic number, only first three magic number are correctly predicted. That was 2, 8, and 20. Okay. So, but at least that success is like at least that infinite square well potential predicted there is a cell structure, right? Then let us solve a problem based on that uh, infinite square well potential. So please write the problem. If nucleus is considered to be a three-dimensional cubical box. If nucleus is considered to be a three-dimensional cubical box, then first three predicted magic number will be that you have to identify. So if your nucleus you are considering like a three-dimensional cubical box, okay, if it is like a three-dimensional cubical box, then according to that three-dimensional cubical box, what will be the first three magic number that you have to identify? Is this question clear to all what I'm saying? Is this question clear to all?
Yes.
Okay. So first three magic number you have to identify. Now we have a three-dimensional cubical box that is mentioned in that question. Okay. It means cubical means length along x-axis should be same as along y-axis. That should be same as along z-axis. And I'll assume that length that is L. And you have learned in quantum mechanics, you have a three-dimensional cubical box, then energy value will be E nx ny nz. That is how much? Pi square h cross square by twice m l square, and then you have this number nx square plus n y square plus n z square. So when you have a cubical, you are thinking your nucleus is cubical shape, right? It means inside nucleus there is no potential, right? But at the edge or at the surface there will be infinite potential, and you have solved this three-dimensional box problem in quantum mechanics, you will get this much energy. Here nx, ny, nz, they can take values like 1 to 3 and so on, and that will be equals to ny and that will be equals to nz. But energy of this box will be quantized, right? Because there is only these integer values are allowed. Okay, so I'll write that combination. So you'll have nx, ny, and nz. Okay, nx, ny, and nz, and number of न्यूक्लियॉन्स. हाँ, इस तरह की प्रॉब्लम बहुत ही इंपॉर्टेंट है, रिसेंटली आया भी था और आगे भी आएगा. नंबर ऑफ न्यूक्लियॉन्स and then you have predicted magic number. So first set of nx, ny, nz, that will be what? क्या हो सकता है first set? So this nx, ny, nz, so grounds for ground state nx, ny, nz, that will be on. So this will be the ground state. So your ground state is actually non-degenerate, है ना. यहाँ पे आपका क्या है, आपका ये set that is your on. Okay, so in that state, how many nucleons can stay? There are 2 nucleons can stay because nucleon is spin half particle. So instead 2 nucleons can stay. So first state is non-degenerate, and this is the state values of nx, ny, nz. That 2 nucleons can stay. Okay, so this will be on closed cell. For that magic number will be how much? That will be 2. That will be 2. So first predicted magic number according to cubical cell, that will be 2. Okay, that is corresponding to your ground state. First, yes.
सर जब हम फर्मियंस के बारे में पढ़ते हैं तो हम यही कहते हैं ना कि एक स्टेट में एक ही फर्मियन आएगा.
नो, स्पिन फॉर स्पिन हाफ 2 रहेगा. एक स्टेट में कितना फर्मियन रहेगा? दैट विल बी योर 2s + 1. एग्जैक्टली.
ओके सर.
ओके.
यस सर.
yes. Any more questions?
Here we are talking.
Yes. Can you please repeat your question? So this is your ground state, and that next.
Sir, here we are talking about fermions.
Your nucleons are fermions, right?
Yes, sir.
And spin is the spin of a nucleon is how much?
Half.
Half. So 2 into half + 1, that will be 2.
Yes, sir. Yes, sir.
That's clearly observable from here. Next state, that will be your first excited state, and for that set of nx, ny, nz can be like this, or it can be like this, or it can be like this. So in that, your first excited state is actually triply degenerate. All state is having same energy, but set of nx, ny, nz is actually different, right? For this it is 2 on, 2 on, and 2 on 2, right? And for every state again 2 nucleons can stay. So this is on closed cell, है ना? Energy separation between first and ground and first excited state is large. So I'll assume this is your on cell. Then next closed cell is here, है ना? ये तीनों का energy same है. This is another closed cell, and that is corresponding to first excited state. And everywhere in every state 2 nucleons can stay. Total nucleons can stay in that first excited state. कितना nucleon रह सकता है? In the first excited state 6 nucleons can stay, right? 2 on 2, है ना? On to on में 2 रह सकता है, and on 2 में 2 रह सकता है. But all this state is having same energy. Okay. So this is the another closed cell, है ना? यहाँ पे कितना न्यूक्लियन रह सकता है? 6. So 2 + 6. 2 + 6, that will be 8. है ना? So please try to understand. This is your closed cell. Next cell is closed here, है ना? तो या 2 पहला का है और यहाँ पे 6 रह सकता है. 2 + 6, that will be your 8. So next predicted quantum number is, magic number is 8. Then again the second excited state is like 2 on, or on 2 on, or on 2, और क्या हो सकता है? और क्या हो सकता है?
2 1 2.
Exactly, 2 on 2. यहाँ पे भी कितना रह सकता है? यहाँ पे भी यहाँ भी आपका कितना रह सकता है? 6 रह सकता है, right? That next state it can stay. यहाँ पे लिख लो बेटर, है ना? यहाँ पे और 6 रह सकता है, तो 2 + 6 8 + 6 14. So next predicted number will be 14. है ना, यहाँ पे लिख लो आप, नीचे इसके नीचे ही लिखोगे, है ना, दैट इज योर 2/2।
सर नीचे से दिखाई नहीं दे रहा।
हाँ ठीक है, मैं लिख देता हूँ।
Sir, second excited state is for L equals to 2, na?
For L equals to or N equals to, right?
L equals to 2.
L is your
Sir, no, that small L. Angular momentum wala.
You tell me here.
Like L0, L1, L2, P wala, P shell L.
नहीं, यहाँ पे आपका सेल का कोई कॉन्सेप्ट नहीं है।
Okay.
Sir,
आपको ये नहीं बोला गया है कि सेंट्रलाइज पोटेंशियल बोला गया है आपको,
No, sir.
not mention centralized potential, so that solution will not be like that.
Okay, sir.
That you have assumed centralized potential, but यहाँ पे सिर्फ simply आपको क्या बोला गया है, three dimensional cubical box. Yes, someone was asking something else. Tell me.
sir, one small doubt. So why we are adding the previous one, nucleons, for finding
Why
the
you are
magic
adding?
numbers? Yes, sir.
हाँ,
Like
इसका
why we are
मतलब
adding
देखो
2
देखो
plus
मैजिक
6?
नंबर समझने की कोशिश करो। तो मैजिक नंबर में आप क्या पढ़े थे कि कोई सेल अगर कोई न्यूक्लियस का, समझ मान लो किसी न्यूक्लियस का 8 प्रोटॉन से, 8 प्रोटॉन्स मीन्स क्या है, यहाँ पे 2 रहेगा और स्टेट में 6 रहेगा, यानी उस न्यूक्लियस का जो प्रोटॉन्स है दे आर एक्चुअली कंप्लीटली फिल्ड, उनका सेल जो है कंप्लीटली फिल्ड, उसको हम क्या कहेंगे, दैट विल बी मैजिक नंबर। तो मैजिक
Yes.
नंबर में हमको आपको ऐड ही करना पड़ेगा ना, इस स्टेट का जितना न्यूक्लियस है ना, उनके साथ नेक्स्ट स्टेट का कितना न्यूक्लियस है उसको आपको ऐड ही करना पड़ेगा। इसका मतलब क्या हुआ कि सपोज मान लो आपके पास कोई न्यूक्लियस का 8 प्रोटॉन्स है, so 8 protons means in that state it will stay 2 protons, the next state there will be 6 protons will stay. It means for that nucleus that cell is completely closed, so it will
Okay,
be
sir.
your magic
Understand.
number.
Understand, sir. Thank you,
So
sir.
I'm writing again here, you have a 2 on, right, and then 2 on 2 and on 2 2. So as a result you will have 6 nucleons. Here you will have 6 nucleons, right? So next magic number will be 14. So if you are thinking that your nucleus is cubical shape, then first 3 predicted, please try to understand, यहाँ पे क्या बोला गया है, predicted magic number. Predicted magic number doesn't mean that experimental magic number like that. यहाँ पे ऐसा नहीं पूछ रहा है कि जो cubical box कौन सा मैजिक नंबर को करेक्टली प्रेडिक्ट कर रहा है, ये नहीं पूछ रहा है, ठीक है ना। करेक्टली प्रेडिक्टेड ये नहीं पूछा गया है, आपको क्या पूछा गया है कि अगर क्यूबिकल बॉक्स होता तो मैजिक नंबर क्या क्या प्रेडिक्ट करते, फर्स्ट 3 मैजिक नंबर क्या प्रेडिक्ट करते, ये पूछा गया है। ये नहीं पूछा गया है कि फर्स्ट 3 करेक्टली प्रेडिक्टेड मैजिक नंबर, ऐसा नहीं पूछा गया, बोला गया है, ठीक है। Well, I'll continue. Next potential, that is your harmonic oscillator potential. Okay, and you know that potential form of harmonic oscillator, that is half m omega square, and then you have r square. So they have assumed that next centralized potential, that is harmonic oscillator potential, and they insert this harmonic oscillator potential in time independent Schrodinger wave equation. Okay, again we can see that potential is actually depending upon potential is depending upon only position vector. So you can basically separate that component of psi. Psi is having three components, r, theta, and phi. And when you have a centralized potential, you can separate that wave function, that component of wave function by using the concept of separation of variable. Okay, so if you write that r component, so r component will be like h cross square by twice m del square by dr square, then you have vr, and then l into l plus 1 h cross square by twice mr square. So this term is arising because of that potential, that is centralized potential. So whenever you have a central potential, this term will get. Okay, so this is the actually r component of your wave function. So whenever you have a symmetric potential or potential depends upon position vector, you can separate that wave function component, because psi is having three components, right? Psi actually depends upon r, theta, phi. You can separate r component, theta component, and phi component by using the concept of separation of variable. And you have learned this in quantum mechanics, that r component actually give you that energy of your system. You have learned this in quantum mechanics hydrogen atom problem. Okay, and this term is arising because the potential is centralized potential. Now the solution of this equation is ENL, that is twice n plus L minus half h cross omega. Twice n plus L plus half h cross omega. Now what I'll do, I'll write that again, ENL, that will be twice n plus L minus 2 plus 2, right? Then half h cross omega. Now I'll combine this term and this term. So I can write like 2 into n minus 1 plus L, and this term I'll add. So 2 minus half, that will nothing but 3 by 2 h cross omega. Okay, and this will be your lambda plus 3 by 2 h cross omega, where lambda is 2 into n minus 1 plus L. Now I'll substitute that, I'll calculate the value of lambda for different n. So better I'll write it in complete way, because it will take much space. I have to use full board. So lambda, I'll calculate lambda for different n, for different L, and then you have an orbit corresponding to L values, and finally I'll calculate ENL, because I have seen that energy is function of n and L, right? So first n values can be what? क्या क्या हो सकता है इनका value? First value minimum, that will be on, right? So I'll use on. So for a given n, for this particular n equals to 1, there are various L values possible, and that can be 0, on, 2, 3, 4. You can extend more if you want. So for n equals to 1, this is the minimum n that is possible, and corresponding L can be 0, 1, 2, 3, 4, and so on. Okay. So for this set, can you tell me what will be the lambda value? लैम्डा की कितना आ जाएगी? when you have a on zero set, because if you remember lambda was like क्या था lambda का expression, that was 2 into n minus on plus L, right?
Yes, sir.
So obviously when you are taking this
Zero.
combination, so for actually for this particular n equals to on, this term will be 0. So lambda equals to L. When n equals to on, that first 2n that term that will be 0. So lambda equals to L. So basically it will be like 0 on 2, 3, 4. And you know for L equals to 0, that is your on s orbit. On means n equals to on, L equals to 0. Second, you have a on p orbit. Third will be on d orbit. Fourth, on f, on g, and so on. If you want more, you can extend n values on and corresponding more L values. Okay. So this for this set, for on s, energy will be how much? That will be your 3 by 2 h cross omega. You can check. You have that energy eigenvalue formula. You can check lambda plus 3 by 2, and lambda is on, sorry, lambda is 0, obviously that will be 3 by 2. Next will be 5 by 2 h cross omega. Next you have on d, and for that it will be 7 by 2 h cross omega. Next on f, for that it will be 9 by 2 h cross omega. And then you have 11 by 2 h cross omega. Okay, there's a possible. Next n values can be 2. So I'll use 2, 2, 2, 2, 2. I don't have much space. Okay, so I have to manage somehow. So I'll use like 2, 2, 2, 2, 2. Can you see that much? Na 5, 2 लिख लो. And again, for this particular set of n, again L can take values 0, on, 2, 3, 4. Now can you tell me what will be? You have a 2, 0. For that lambda will be how much?
4.
Huh?
And 2, sir.
Okay, first will be 2, then 3, then 4, then 5, then 6. And of course, for this set, 2 equals n equals to 2, L equals to 0, it means this is your 2s. Then 2p, 2d, right? Then 2f, and then 2g. So first, this is your n, and corresponding L will give SPD, and so on. To calculate that energy, now can you please tell me what is the energy of 2s? That will be
7 by 2.
7 by 2 h cross omega. Then 9 by 2 h cross omega. Then 11 by 2 h cross omega. Then 13 by 2 h cross omega. And next one or last one will be 2g. For 2g energy will be how much? Here I am writing. That will be 15 by 2 h cross omega. है ना? लिख लो आप लोग, शायद दिख नहीं पा रहे हो. 9 by 2 के बाद दिख नहीं पा रहे हो ना. So 9 by 2 means you have a 2d. For 2d it is no. For 2p it is 9 by 2. For 2d it is 11 by 2. So for 2d it is 11 by 2. For 2f it is 13 by 2. And for 2g it is 15 by 2. Both easy है देखो. 7 by 2, 9 by 2, 11 by 2, 13 by 2, 15 by 2 h cross. And that wholly depends upon this lambda, because E is nothing but lambda by 2 lambda plus 3 by 2 h cross omega, है ना? तो यहाँ से देखो ये शुरू हो रहा है repeating 2, 2, 3, 3, 4, 4 and so on. So these are the possible values. But how I am calculating this? How I am calculating? Can anyone guess? I can see these values.
Spectrum.
I can see. You see here that 7 by 2 h cross omega. For on D there is a energy that is 7 by 2 h cross omega, and here also you have a 7 by 2 h cross omega, and that corresponds to what? The 2s. The 2s. It means on D and 2s they are basically degenerate set. Similarly, you can see 2p. 2p having energy 9/2, and that is perfectly matching with
1F.
on F. Next, you have a on G. That is matching with what?
2D.
On G is matching with 2D और किसके साथ मैच करेगा? On G is matching with 2D, and you have a 3s also, है ना? 3s का एनर्जी कैलकुलेट करोगे वो भी आपका, so on G, then you have a 2D, right? On G, 2D and 3s, है ना? इनका सारे का तीनों का एनर्जी एक मिलेगा. You can check when you have a n value that is 3 and L equals to 0. You can calculate that energy. You will get this much energy, 11/2 H cross omega. It means on G, 2D and 3s, they are also degenerate. So at least when you are taking harmonic oscillator potential, you are getting some degenerate state. So we can see that discrete energy. So of course that nucleus is having cell structure. In addition to this, there's some degenerate state are there. So when you have a degenerate state, that will reduce some or reduce few magic number, है ना? इनफाइनाइट स्क्वायर वेल में तो काफी सारे मैजिक नंबर को प्रेडिक्ट किया था, है ना? उनमें से आपका 3 ही करेक्ट था. इनमें डिजेनरेट जब आप इसमें डिजेनरेसी इंट्रोड्यूस हो रहा है, सो देयर विल बी रिडक्शन इन द few closed cell structure. I mean number of closed cell will be reduced, है ना? So they will predict less number of magic number. But यहाँ पे भी आपका 3 ही करेक्ट हुआ, that I can see. I'll check. Well, so you have a first जो आपका ground state कौन सा था आपका? Can you tell me now? Tell me one by one. First ground state, right? So if you see that first state was your ground state because it has least energy, that was 3/2, and that is corresponding to what? On S, right? According to harmonic oscillator, आप देखो सारे एनर्जी वैल्यू देख के आप पता कर लोगे कि मिनिमम एनर्जी दैट corresponding to on S. Next किसका है? Tell me.
1D.
Next is your
1D.
on.
1D.
Exactly. Next
1D.
1D.
on D and
2S.
S. So this state corresponds to on D as well as 2S. They have same energy. Next
2P.
2P and on F. So
2P
on
and
F
1F.
and 2F. Sorry, 2P. Next
1G,
2D.
2D and 3S.
exactly on G, 2D and 3S. Now tell me how many nucleons can stay here?
2.
And corresponding magic number will be 2. यहाँ पे कितना रह सकता है?
6.
6. So 2 plus 6, that will be another magic number, that will be 8. यहाँ पे कितना रह सकता है?
Maybe 12. 10. 12. Sir.
12. D में 10 रह सकता है, आपका S भी
Yes,
है.
sir.
So 10 plus 2, 12. And corresponding magic number will be
20.
next. अगर आपको याद है यहाँ पे इनफाइनाइट स्क्वायर के लिए एक और मैजिक नंबर आ गया था, राइट? 18, है ना? That was actually wrong. यहाँ पे कितना रह सकता है?
14 plus 6.
14 plus
20.
6, 20. Corresponding magic number?
40.
So very easy. 2 first, 2 plus 6, 8. Second magic number. Third, 2 plus 6 plus 12, 20. Fourth, 20 plus 20, 40. वैसे भी कर सकते हो. 2 plus 6, 8. 8 plus 12, 20. 20 plus 20, 40. Next, यहाँ पे कितना रह सकता है? On G में कितना रह सकता है?
18.
18 करेक्ट. D में 10.
10.
ग्रेट. S में
2. Total 30.
30. So next magic number क्या आ जाएगा?
70.
Exactly. And there are few more also. I can see that harmonic oscillator actually correctly predicted this many these three magic number. That was actually experimentally massive. But interesting thing, it introduced that degeneracy, and when there is a degeneracy, that will actually reduce that number of predicted magic number. ये अगर अलग अलग होते हैं ना, on G 2D and 3S अगर अलग अलग होते तो इसका corresponding आपका हर एक के लिए अलग अलग magic number मिलता. So when they are merging together, that is actually reducing that number of prediction in the magic number. Are you getting what I'm trying to say? But yes, there is a failure again. It's not correctly predicting all that magic number. Next is your Wood section potential. Wood section potential. And that form of Wood section potential is V of R, that is minus V naught divided by 1 plus exponential R minus R by A. Okay. You see that nature of potential that can also ask in the interview. So it will have this kind of behavior. So it will be like this. Here you have some V naught like that. And here you have 0. Not V naught exactly, some negative number. Not writing. So this is your positive number this side, and this side you have some negative number. So they have introduced this Wood section potential in Schrodinger wave equation again. What is V on? V on is the some potential value, and they have chosen this value for this calculation, that is 50 mega electron volt. They have taken that value of A also, that is 0.52 femtometer. Okay, this is constant, So to solve this equation in Schrodinger, if you when you are inserting this, you have to choose this constant value as well. So they have taken for the calculation that potential V naught, that is 50 mega electron volt, and A, this is also constant. They have taken this is 0.52 femtometer, and they have solved that Schrodinger wave equation again. So when they are solving that Schrodinger wave equation, so they are predicting the magic number like this. The predicted magic number, that was like 2, 8, 20, and then you have 40, 58, 92. Okay, and you have on 2. So this many magic number they are predicted when they are taking Wood section potential. Okay, and these are the value they have taken for the calculation or for the prediction of this magic number. So they are inserting this centralized potential in Schrodinger wave equation, and they are taking V naught and A values like this, and they are predicting these are the magic number. But out of this magic number, only I can see only this first 3 magic number is correct, and rest of the magic number are actually wrongly predicted. But yes, number of predicted magic number, you can see this actually reduces. तो बहुत सारे में से 3 ठीक है, और यहाँ पे only they have predicted this many, and out of this 3 are correct. 3 are correct.
So in this case also, due to degeneracy, these last 3 are not correct.
जी कौन सा ये वाला?
Yes, the last 3.
Last 3 ये वाला ये?
Yes, sir. So due to degeneracy, in this case also they are not
degeneracy
correct.
here also there is a of course there is a आपको देखो नंबर ऑफ रिडक्शन हो रहा है ना, आपका यहाँ पे क्या हो रहा है, रिडक्शन हो रहा है ना। तो लास्ट 3 क्यों बोल रहे हो आप, आपका लास्ट 4 है ना, 40 भी तो रॉन्ग है।
Yes sir, yes sir.
लास्ट 4 आपका ये रॉन्ग है। क्यों रॉन्ग है, उसीलिए हम जाएंगे अभी। व्हाई देयर इज अ प्रॉब्लम, है ना। दे आर टेकिंग सेंट्रलाइज पोटेंशियल बट करेक्टली प्रेडिक्ट हो रहे हैं 3। बट हाँ, यू कैन आस्क मी व्हाई देयर इज अ रिडक्शन अगेन। सो रिडक्शन जब भी हो रहा है, इसका मतलब क्या हो रहा है, जस्ट
Sir?
हाँ
So due to degeneracy, there is the
Exactly.
reduction in the magic number, na?
एग्जैक्टली
That is
यहाँ पे
that
भी, यहाँ पे मोर एंड मोर डिजेनरेसी आ रहा है। दैट्स व्हाई देयर इज अ मोर डिक्रीमेंट इन द मैजिक नंबर वैल्यूज और नंबर ऑफ मैजिक नंबर।
सर डिजेनरेसी की वजह से ये तो नहीं है ना कि 3 मतलब जो 3 या 4 आ रहे हैं मैजिक नंबर करेक्ट, वो डिजेनरेसी की वजह से नहीं आ रहे,
कौन सा ये,
ऐसा नहीं है ना सर? हाँ जी।
नहीं वो तो आपको मैंने अभी सिखाया कैसे मैजिक नंबर आया है। तो वैसे जैसे आपका क्या, आपका आप श्रोडिंगर वेव इक्वेशन में क्या करते हो, श्रोडिंगर वेव इक्वेशन एक्चुअली गिव यू क्वांटाइजेशन ऑफ एनर्जी, ओनली फ्यू सेट ऑफ एनर्जी वैल्यूज आर करेक्ट। इनफाइनाइट स्क्वायर वेव में प्रॉब्लम क्या था कि देयर आर मेनी एनर्जी लेवल आर पॉसिबल, ऑल आर नॉन डिजेनरेट, है ना। तो हर एक
Yes, sir.
लेवल तो एक लाइक है सेल ना, वहां पे बहुत सारे सेल पॉसिबल है एंड दे प्रेडिक्टेड मेनी मैजिक नंबर। हार्मोनिक
Yes.
ऑसिलेटर में कैसे रिडक्शन हुआ है, जैसे क्वांटाइजेशन ऑफ एनर्जी बट there's a इंट्रोडक्शन ऑफ डिजेनरेसी। सो डिजेनरेसी जितना ज्यादा डिजेनरेसी इंट्रोड्यूस हो रहा है, उतना ही
Yes.
नंबर ऑफ प्रेडिक्टेड मैजिक नंबर कम हो रहा है। तो यहाँ पे नंबर ऑफ प्रेडिक्टेड मैजिक नंबर कम हुआ, इसका मतलब क्या है, यहाँ पे देयर आर मोर नंबर ऑफ
Degeneration.
डिजेनरेसी दे हैव ऑब्टेन।
Okay.
Okay, so that problem is not solved yet. The problem is actually not solved yet. Then what they have done, they have taken wood section potential and plus spin orbit coupling. So as you know, just you have learned that your each nucleon is having orbital motion, right? Each nucleon is having orbital motion that is given by orbital quantum number L. And you also know that each nucleon is having spin. So you have an orbital motion at the same time, your nucleon is having spin motion at the same time. So there will be definitely some spin orbit coupling here also, that actually missed in previous calculation. And that's why actually they're not correctly predicting that all magic number, because you have some spin orbit Hamiltonian or spin orbit potential. If you are missing that, obviously you will make some wrong calculation. So in that part, they actually introduce that spin orbit coupling. Why they are introducing spin orbit coupling? Because just we have discussed in last class that you have each nucleon is actually having orbital motion, and we know that during orbital motion, each nucleon is actually spinning also. And in atomic physics, you learn this thing, that LS coupling, that arises because of orbital motion and spin motion coupling. So they basically taken wood section potential, but they are adding that spin orbit coupling. So if you have, so they are taking this, but additional they are taking spin orbit coupling Hamiltonian, and that is FR L dot S. Well, FR is the strength of the coupling. FR is called strength of coupling. Strength of coupling. Okay. So they have calculated that Wood section potential, and I mean they have assumed that Wood section potential, and they inserted that in Schrodinger equation that Wood section potential, they have obtained that values. But there is a perturbation here. This perturbation should be included in the energy values, and if you include, then you will get correct description of energy of your system. And this is the perturbed Hamiltonian. So what is the perturbed energy corresponding to that? So when you are taking Wood section potential and you are inserting that in a Schrodinger equation, you will get some energy eigenvalues. But this is not correct because your system is part of, there is a LS coupling. So this is the part of Hamiltonian. So you have to calculate that part of energy, and that you have to add in that unperturbed energy. That will be the correct description of your energy. Now, can you tell me what will be the spin orbit energy or part of energy? How will calculate? So we'll have like HSO expectation value that you have learned in quantum mechanics. If you do that, so this is like your minus FR, that will be outside. Okay, and you have L dot S. You have to calculate that expectation value of L dot S. By the way, I should say that FR is the strength of coupling, and that will be some positive number. That will be some positive number. Now, can you tell me how will calculate that expectation value of L dot S? So you know this, you have a J equals to what? L plus S, right? J equals to L plus S. Now if you multiply J both sides, what will happen? You will have L plus S dot L plus S, right? You'll have this. So on the left hand side, J dot J, that will give you J square, and that will be equals to L square plus S square plus twice L dot S, right? If you break this, L dot L, that will be L square, S dot S, that will be S square, and that two terms, that will be twice L dot S. From here, I'll get that value of L dot S, and that will be J square minus L square minus S square by 2. J square minus L square by minus S square by 2. Now, can you tell me what is the expectation value of L dot S? So expectation value of L dot S means expectation value of J square minus L square minus S square. Expectation value of J square कितना होती है? कितना होती है? Tell me, हाँ ना बोल दिया करो, या नहीं आता तभी बोल दो. Then I can understand ना. J square का expectation value कितना होती है? You learn this, right? When J square operating on psi, what will happen? You will have J into J plus on H cross square, right? So this is the expectation value of J square. If you take psi here, right? So this will be normalized, and this will be the expectation value that you have learned in quantum mechanics.
Yes, sir.
So we'll have J into J plus on minus L square का कितना होता है? L into L plus on, and then you have S square, S plus on, and in the whole you will have H cross square, right? सारे में से H cross square common मिलेगा, and you will have it means ESO corresponding to or I can say ESO कितना आ जाएगा? Minus FR, and then you have this factor J into J plus on minus L into L plus on minus S into S plus on, right? And then you have H cross square by 2. Tell me if I made any mistake. You can keep that FR outside also. That's not a problem. I should keep outside because you have a H cross square here. Okay, na? Now, can you tell me what is the possible value of J? क्या का possible value हो सकती है J का? So nucleon is spin half particle, right? You learn this. We have started from here itself. That J equals to L plus S. Now for nucleon, S is for nucleon, है ना, mod J का वैल्यू क्या क्या हो सकती है बताओ?
L plus S to L minus S.
हाँ, S कितना है? न्यूक्लियन है, so it can take L plus half or L minus half. These are the two possible values of J. J और magnitude of J. जैसे आप वेक्टर को हटा रहे हो, इसका मतलब you are calculating magnitude. So since nucleon is spin half, so S is half. So that magnitude of J can take like L plus S, L plus half either or L minus half. So it means if you calculate that ESO, spin orbit energy corresponding to J equals to L plus half, can you calculate and tell me कितना आएगा? Calculate करो जरा. What I'm saying, please calculate that spin orbit energy corresponding to J equals to L plus half. So you have minus FR, that is outside. In place of J, I'll substitute L plus half. So J into J plus 1 means L into L plus 3 by 2 minus L into L plus 1 minus S का वैल्यू कितना है? हाफ है, so S into S plus 1, that will be 3 by 4, and you have 2, and of course there is a H cross square here, है ना? It means minus FR. Okay, now if you break this, how much you will get? L into L square, then 3 by 2 into 1 by 2, that will be 3 by 4, and 3L by 2 plus L by 2, that will be 2L. To break this, L into L plus 1, that will be minus L square minus L minus 3 by 4. Okay, and then you have H cross square by 2. So this 3 by 4 will be cancelled, L square will be cancelled, 2L minus L, that will be L. So as a result, 2L minus L, that will be L. So minus FR L H cross square by 2. That's really important. So basically two perturbed energy is possible. One is ESO corresponding to J equals to L plus half, that will give you the perturbed energy, that will be minus FR L H cross square by 2. FR is some positive strength coupling. Now again, if you calculate ESO corresponding to J equals to L minus half, again you will have minus FR, and the first two term will be L plus half into L minus half. J plus 1 into J. J is L minus half, J plus 1 will be L plus half. And then you will have L into L plus 1 again, right? Minus 3 by 4, that is S into S plus 1. Divide by 2, and you will have H cross square. You will have H cross square. You will have H cross square. Now can you calculate and tell me how much you will get? ESO, that will be minus FR.
So last term क्या लिखा आपने?
Last term as it is वैसा है, क्या होना चाहिए last term? S
Sir, minus
S का
1 by
मतलब क्या है? S तो आपका हाफ ही है ना? S that will be minus 3 by 4 again, because S is half. जब आप J equals to L minus half ले रहे हो, इसका मतलब थोड़ी ना S equals to minus half है. L and S they are anti-parallel, है ना? So S will always be half, irrespective to J equals to L plus half or L minus half. So last term will be minus 3 by 4, and you have H cross square. समझ रहे हो ना मैं क्या बोल रहा हूँ? मैं बोल रहा हूँ J equals to L plus L minus half क्यों ले रहे हो? इसका मतलब यही हुआ, this is the case when L and S are anti-parallel. But it doesn't mean that spin value is negative. Spin will always be taken positive number. Okay.
Minus half L plus 1 H cut square by 2, sir.
You will have minus L minus 1 H cross square by 2, like that.
Yes, sir.
You will get that, because this will be your L square minus 1 by 4. You will have L square that will be cancelled, right? L square will be cancelled, and then minus L will be here, and minus 1 by 4 minus 3 by 4, that will be minus 1. So minus L minus 1, and you have 2 factor H cross square. You can bring that minus, you can take common, and that will be cancelled. So now total energy, you have a total energy of a system. That will be what? Your unperturbed energy, that will be E naught, and then you have a perturbed energy S. And that perturbed energy can take two values. One is minus FR LH cross square by 2, and another is plus FR LH cross square by 2. It means for any state, for any L state other than L equals to non-zero, other than L equals to 0, that every state will be split into two different state. मैं कहना चाह रहा हूँ, सपोज मान लो आपके पास सपोज मान लो कोई आपका ऑन स्टेट है. If you add perturbed energy here, there will be no further splitting of on state. There will be no further splitting of on state, क्योंकि यहाँ पे क्यों split नहीं हो गई on state? Can anyone tell me?
L is equal to 0.
L equals to 0, there will be no further spin orbit coupling. But if you take, like, suppose you have a on p state, this state will be split into two parts. Why? Because we'll have two different spin orbit or the different perturbed energy. On perturbed energy, like minus FR LH cross square by 2, it means there will be, when you will add this energy minus FR LH cross square by 2 with unperturbed energy, there will be downward shift. Okay, but if you add this energy, when you will add this energy P plus FR LH cross square by 2, it will be upward shifting. So it means this state corresponding to J equals to L minus or plus?
Minus.
Minus?
Plus.
It should be plus, because this minus you are getting when you have a J equals to L plus half, and this will be corresponding to J equals to L plus half. Now can you tell me what is the
So minus ऊपर वाली.
हाँ जी, हाँ exactly. नहीं ये exactly, very good. It will be minus. Can you tell me what will be the separation between these two level? कितना separation आ जाएगा? Can you please tell me what is the separation? This is really important for your exam. कितना आएगा?
FR H cut square.
This separation, if you denote delta E, that will be depends upon ESO at J equals to L plus half minus ESO J equals to L minus half. है ना? You have obtained these values, you have obtained these values. So this will be the total separation. A higher minus lower, that will give that this separation. If you calculate this separation, you will get delta E, that will be FR into
H cross square by
12 plus on H cross square by 2. So it means for P state, it will be how much? For P state, L will be on, so this will be like, कितना जाएगा? For P state, it will be 3 FR F by 2 H cross square. Right? For D state, it will be how much? Next state is your D state. Suppose you have a on D state. So D state के लिए again there will be two level splitting, है ना? तो यहाँ पे splitting ज़्यादा होगी कम होगी? This delta E will be how much now? When you have a D state. So it will be, you check करो, that will be 5 by 2 FR H cross square. because you have a delta E depends upon what? FR 2L plus on H process square by 2, and for D L equals to how much? 2. So what I'm trying to say, if you increase that if you increase that L values, the splitting will be large. Splitting will be large. So for any L equals to non-zero state will be split into two states. Upper state will be corresponding to J equals to L minus half, and lower state will be L plus half. Okay. Now, why I'm discussing this much? Because we'll directly get question. If I ask that question, can you please check?
So can you please repeat last thing?
लास्ट थिंग मैं कह रहा हूँ डेल्टा ई का वैल्यू किसके ऊपर डिपेंड है, किसका प्रोपोर्शनल टू है?
Sir, L.
L.
हाँ, तो एल लार्ज है, इसका मतलब डेल्टा ई लार्ज है ना. फॉर एनी लार्ज एल वैल्यूज, जैसे एल के लिए पी के लिए जितना डेल्टा ई है, डी के लिए उससे ज्यादा हो जाएगा है ना, एफ के लिए उससे भी ज्यादा हो जाएगा, एंड सो ऑन.
Okay.
Okay, I'll give that also. Suppose your spin orbit coupling is given for nucleus. HSO is given for nucleus, that is A L dot S. Okay. You have to calculate delta E. You have to calculate delta E for delta E between on F 7/2 and on F 5/2. बताओ जरा, डायरेक्टली बताओ. डी के लिए क्या क्या स्टेट पॉसिबल है, पहले बताओ. पी के लिए क्या क्या पॉसिबल है? P 3/2 एंड P हाफ. डी के लिए J इक्वल्स टू L प्लस हाफ एंड L माइनस हाफ करोगे ना, तो P के लिए क्या है? ऑन प्लस हाफ एंड ऑन माइनस हाफ. डी के लिए 2 प्लस हाफ एंड 2 माइनस हाफ. जो स्टेट आप लिखते हो ऐसे, सपोज मान लो ऑन पी स्टेट है, सपोज मान लो जब स्प्लिट हुआ है, इसको कैसे रिप्रेजेंट करोगे? सो दिस विल बी लाइक ऑन पी J इक्वल्स टू क्या है? L माइनस हाफ. L कितना है यहाँ पे? ऑन है, सो दैट विल बी ऑन पी हाफ. यहाँ पे क्या हो जाएगा? ऑन पी 3/2. ठीक है ना. तो यहाँ पे यही स्टेट है, ये दोनों स्टेट है. ठीक है, इनके बीच में कितना सेपरेशन है? देखो बड़ा सिंपल है. जो हाईएस्ट J है, हाँ, सो दैट विल बी कॉरस्पॉन्डिंग टू 7AH प्रोसेस स्क्वायर. चेक करो, जब आपका D था कितना था? D के लिए 5/2 FRH प्रोसेस स्क्वायर. P के लिए कितना था? 3/2 FRH प्रोसेस स्क्वायर. आप कैलकुलेट भी कर सकते हो, है ना. तो ऑन F 7/2 ऑन F 5/2 है ना. ये आपका रिसेंटली क्वेश्चन है ना, रिसेंटली आया है ये गेट पर.
Yes, sir.
तो आराम से कर सकते हो. 7/2 FR का वैल्यू यहाँ पे क्या है? A है.
A.
डायरेक्टली कर दो. ठीक है. So I think I should stop here because I have to discuss.
Sir.
I have to take one more class.
Sir,
हाँ जी, बोलिए.
sir, this part, sir, last what you have told, I didn't understand. Sir,
Which part
1p 3/2. Sir, you have told to find the separation between these two, right?
Yes.
So 1f 5/2. So how you have 2l plus 1/2 is the separation.
तो
FR
if you
12
do
plus
that,
1
how
by
much
2
you will
h
get?
cut.
Tell me. If you do that, how much you will get?
So L is 3
बड़ा
here,
सिंपल
right?
है. यहाँ पे जैसे आपका डेल्टा क्या है? FR
12
by
plus
2
1 by 2.
12 plus 1, right?
Yes.
H plus square. चलो FR क्या दिया है यहाँ पे? A given. देखो यहाँ से पता चल रहा है ना. A
Yes,
given.
sir. Yes, sir.
और F के लिए L कितना है?
3.
3 है. तो 3 into 2 6 plus 1 कितना है? 7 है. और करने का जरूरत नहीं है, देखना जो लार्जेस्ट J है उसका कॉरस्पॉन्डिंग ही मिलता है. ये मैं कहना चाह रहा हूँ. जैसे आपका ऑन बी का हाफ 3/2, तो आपका डेल्टा ई 3/2 इंटू FRH प्रोसेस का. डी के लिए 5/2 3/2 होती है. राइट। जे का वैल्यू 5/2 3/2, तो उसका
Yes, sir,
कॉरस्पॉन्डिंग
sir.
डेल्टा ई क्या होगा, जो लार्ज जे है उसका कॉरस्पॉन्डिंग लार्ज जे इंटू एफ आर एच क्रॉस स्क्वायर। यहाँ पे लार्ज जे
Okay,
क्या
sir.
है 7/2, एफ आर गिवन है ए इंटू एच क्रॉस स्क्वायर, दैट्स इट। ठीक है ना। Well, I should stop. Tomorrow I'll have to take one more class. Then I think I can finish. Okay.